Okay, finally, about exponential distribution, here I'm going to give you an alternative parametrization. Alternative parametrization. So the distribution is still the same, but the representation of it is a little bit different. Here, the parameter is usually denoted with a mu. And you see, essentially what we have is mu equal to 1 over lambda. That's the only difference. Okay, here you see instead of lambda e to the power lambda x for the PDF, you have 1 over mu times e to the power minus x over mu. Okay, and the CDF is given by 1 minus e to the power x over mu for non-negative x values. And if you compute the expected value, second moment, and the variance, they turn out to be mu, 2 mu square, and mu square. So mu here is, you see, the mean of distribution. So sometimes people prefer to parameterize the exponential distribution using the mean rather than the reciprocal of the mean. So the reciprocal of the mean has an interpretation. We sometimes call it the rate of the exponential distribution. And mu here obviously is the mean of the distribution, and the mean and the rate are reciprocals of each other. So in certain contexts, we prefer to use the parameterization with lambda, and in this course we are going to do that. But in some other contexts, just bear in mind that there is an alternative parameterization for the exponential distribution, which is where the mean value is used. In fact, let me just give you an example from MATLAB. We have this function defined in MATLAB, xrand, exp rnd. So here you provide a parameter, let's say that is 100, and MATLAB produces you a random variable or random number, let's say, that has a distribution which is exponential with a mean of 100. Okay, so if you just know the lambda value, in this case that would be 0.01, and therefore you would have to provide to MATLAB 1 over lambda as the parameter of this function, so that it produces you a random number from this the intended distribution. Okay, so in certain contexts, exponential distribution is parameterized using the mean value rather than the rate value.